Hi and welcome. In this lecture, we are going to introduce one of the most fundamental results in the whole of probability theory and statistics, namely weak law of large numbers, WLLN. To start off, let's consider an example. For that, we have a population of students with 12 members. So that's a class with 12 students in it. And we have data on their current score. So that's 80.1, 95.24, and so on and so forth. If you calculate the mean of this score variable, you get 82.43. Now, this is the population of the mean because we have the score of all students in this class. Now, in a hypothetical situation, suppose we draw a random sample from this population and check how close the mean of the sample is to mu, which is the true population mean. Remember that when we are working with samples, our mean, which is then calculated using sample data, carries with it some error because we are using part of the data, not the entirety of the population data. Therefore, whenever we are working with sample, depending of course how large the sample is and whether we have chosen this sample randomly, there is always some error in the value of the sample mean or sample standard deviation or whatsoever that we calculate using sample data in comparison to true population parameters. Remember that in the population, we have population parameters such as the mean of the population, the standard deviation of the population, and so on and so forth. When we take a sample out of this data and we do it repeatedly, for example, we select a sample of 3 students and we do it 1,000 times. That means we have 1,000 sample, each of which has 3 members. Then we calculate, for instance, the mean for each of the 1,000 samples. Then we will be having 1,000 values of the mean, each of which is calculated using a sample that's being drawn randomly from the same population. Now, since we have 1,000 numbers, then that 1,000 number has a distribution, and that's called the sampling distribution of the mean. In this case, it can be also standard deviation or whatever else. The law of large numbers says that in some sense, the mean of large, then the law of large numbers says that in some sense, the mean of the large sample is close to the mean of the population. Let's consider a sample of x1, x2, x3 up to xn, which are IID. Then the mean is xn bar 1 over n, the sum of xi. Then the weak law of large numbers says that the sample mean, in fact, converges at probability to the population mean. Remember that we do not have the population mean. That's why this weak law of large numbers is so magical. We don't know the population mean because normally if we know the population mean, why we should take the sample? If we know the population mean, that means we have population data, and we have population data, there is no need of sampling. Population data is not given, therefore population mean is not known. But it's being shown by this very strong result that the mean of the sample, if the sample is large enough, if the sample is drawn randomly, converges in probability to the mean of the population. And what is the benefit of this? The benefit of this is this, that if we have a sample from a given population, if this sample is large enough and if this sample is drawn randomly, we know that in probability the sample mean converges to the population mean, and somehow we get some information about the population mean, which is actually a very, very good information using the sample data.